back. Example, let's find the least squares equation relating the variables of x, size of caribou population, and x and y, it should be y, size of wolf population. Note caribou population is in hundreds. X is the explanatory variable, y is the response variable. So you have x, y, x squared, that is squares of x's, y squared, that is squares of y's, x times y, that is x times y. Add them all up, add these all up, add these all up, add. Now you need to use these sums, summation and summation y, to find x bar and y bar. Okay, once you have x bar and y bar, you can find b, a, and so on. X bar is summation x over number n, right? Total number of points. This is the approximate value. Y bar, that is the mean of y, summation y over n, which amounts to this much. Now b, this is the formula. All right. So you are simply substituting the numbers you calculated in your previous table. You have your b, that's approximately this. What is a? A is y bar minus b x bar. Okay, so this has to be corrected, guys, this slide. A is y bar minus b x bar. So y bar you found already, right? X bar also you found, and b also you found. So y bar minus bx bar gets me a. Once you have a, note calculators give values approximately this, that's close to this, and a approximately this. These values differ slightly from those you computed using the formulas because of rounding. So you have a and you have b, that gets us the y hat, which is a plus bx. Okay, so a plus bx. All right, so that is y hat. So this is equation of the least squares line. Okay, and you use y hat for prediction purposes. Now graph the equation of the least squares line. To graph the least squares line, we have several options. One is slope-intercept method. It's not always convenient because your slope or your y-intercept, it's kind of tedious to draw sometimes, right? It may not be within the range of the sample data values. It's just as easy to select two x values in the range of x data values, then use the least squares line to compute two corresponding values. What are they saying? Choose some x and y. In our case, by the way, this is x bar, this is y bar. All right. So we already have the coordinates of x bar, y bar on the least squares line. So the mean of x's and the mean of y's is already on your line. Another x value, take some x equals 34 and use the y hat equation, plug in x equals 34. Why did we choose 34? Look at our table. So 34 is here, you see. It's one of these. That's what we are doing, right? So here is it. Plug in x equals 34 in your least squares line equation. You get an approximate y value. Okay, so use that with 34 and your anyway x bar y bar and join the line. You see your y-intercept in this case comes here, but the line is pushed in, so you don't want to have difficulty with the y-intercept. So it's better to choose your x bar y bar as one point and some other point, any other point, using your y hat line. That's your least squares line. Notice the actual value for 34 is 75. It's higher, looks like 80. So this is the point you got using y hat. So there you go. That's your least squares line. Now, in the equation, y hat is a plus bx. The slope b tells us how many units y hat changes for each unit change in x. So, regarding size of wolf and caribou populations, this is what you get. What does the slope 1.60 tell us? Tells us if the number of caribou in hundreds changes by 1. So for every change increase by 100, we expect the sustainable wolf population to change by 1.60. When x increases by 1, x increases by 1.60. Our model says that an increase of 100, why 100? Because it's 1. Every count in x is counted in hundreds, you see. Increase in x by 1 means I have increased the caribou population by 100. That will increase the predicted wolf population by 1.60. If the caribou population decreased by 400, we predict the sustainable wolf population to decrease by 6.4. Where did that 6.4 come from? It's 1.6 times 4. That is 6.4. So decrease by 4 gives me decrease of wolf population by 6.4. The slope of the least squares line tells us how many units the response variable is expected to change for each unit change in the explanatory variable. The number of units change in the response variable for each unit change in the explanatory variable is called marginal change. What is marginal change? It is essentially the slope of your y hat line. Marginal change is the slope of the least squares line. Some points in the data set have a strong influence on the equation of the least squares line. For instance, a data pair is said to be influential if removing it would substantially change the equation. So, figure 4.12 shows two scatter diagrams produced in Excel. 12A has an influential point. So this is your 12A initial, and here is with one of the point removed. So that point has been removed, and now the line is slightly flatter. Okay, so figure 4.12b shows the scatter diagram with the influential point removed. Notice that the equations of the square lines are quite distinct. 1.45x plus 1.75, and over there 3.47x minus 6. So you see, with the removal of this 1 point, my line itself changed. So what this point is a data pair. Every point is a pair, right? X coordinate, y coordinate. A data pair is influential if removing it would substantially change equation of the least squares line or other calculations associated with linear regression. An influential point often has an x value near the extreme high or low value. So x value, if it's very far away or very low, then that is a potential influential point. That gives you, I should say it correctly. If a point is influential, chances are its x coordinate is very high or very low. That's what they're saying. All right. So there you go. Okay. If a data set has an influential point, look at the influential point carefully to make sure it is not the result of a data collection error. So when you are working on such matters in your own statistical study, if you find an influential point, check again. Maybe there is a data collection error or data recording error. Okay. A valid influential point affects or changes the equation of the least squares line. The group project in data highlights at the end of this chapter further explores influential points. Okay. So influential points are important to see because they don't fit the pattern. They don't fit the pattern. So here is a pattern and that seems way off. So when you are working on some statistical project and you get something way off, have a look at your data again. Maybe there is some mistake somewhere. If there is no mistake, then that is a matter of study for future. All right. So coefficient of determination. So we'll come on to this topic in our next video. Until then, bye.